Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with number 87 in your homework. And as I read the question, here, we've got this system swinging back and forth here. It's kind of a pendulum type of problem. This thing's fixed at A though, so this thing can't move. I would say that probably that means our point C here also is fixed. And what I was just thinking about before I started the video is, could we possibly define our system as the whole kit and caboodle? If we did, let's see what would happen. You know, we're going to have definitely a reaction force here, another vertical reaction here, only a vertical reaction at B. Any forces at C are internal to the system if we define our system like this. And now we kind of look at our inertial terms. Oh, whoops, one more. And then we'd have a gravitational force here at G for our ice cream cone looking thing. Now as I look at this and we think about unknowns here, all these reaction forces are unknown. There's 3 of them for sure. In addition, this thing is going to have an angular acceleration, a theta double dot, which we're not going to know. So that's 4 unknowns. We can only write 2 force and 1 moment equation for the system. So we can write 3 Newton's second law equations. And you know, sometimes you can write another kinematic equation, like if we had 2 unknown accelerations, we can kind of relate them, but I don't see that we do. The angular acceleration of this object definitely is an unknown. You know, if I think about the kinetic part of it, the kinetic diagram here, we're going to have a centripetal this way, an mr omega squared, a tangential, so we're going to have an ma tangential, and an angular acceleration. These 2 are related, so that's effectively still 1 unknown. And I don't think we're going to be able to solve it like that. So my suggestion for this problem is to start with a free body of the ice cream cone only. So if we think about what a free body of this cone is going to look like, we're going to have the single gravitational force I have drawn. We're going to have a reaction at C. We might call it like a CX, CY. Now the kinetic terms, and again, you want another picture of this to put the kinetic terms. I'm going to go ahead and just do this in this picture. We're going to have an MA tangential in this direction. We're going to have a centripetal, and mr omega squared in that direction. And in addition to that, we're going to have an angular acceleration. I'm going to go ahead and put an I alpha term about the center. If we write a moment equation about point C, the net moment is going to be mg times 0.75 cosine theta. I imagine theta is given in the problem. Then we're going to have kinetic moments, ma tangential times 0.75 and a 1/2 I alpha, I'm sorry, not a 1/2, an I alpha term, and actually that's going to be in, let's see, nope, that is going to be in this direction. So the kinetic side of this is going to look something like ma tangential times 0.75, and that's going to be clockwise. Then we're going to have an I alpha term, and these are going to be related because this is rotation about point C. The tangential is going to equal 0.75 times alpha. So the right-hand side of that equation will look something like that. The left-hand side is going to be mg times this distance. That's going to give you an equation, and I think that's going to allow you to find the alpha and the tangential acceleration. Once you find those, then move over, or then write a force equation in the y direction, force equation in the x direction. That's going to give you the CX, CY. Then do a free body of just this structure here by itself. And when you do that, you're going to have the CX that I have to the right, that will go to the left in your free body of this part. And the CY that I have up will go down on this animal. And this thing right here is static, it's not accelerating. So you can write a force equation x direction to get this. A moment equation about point A will get you this. A force equation y direction will then nail this down. So my advice in this problem is a free body of just the ice cream cone part, That should allow you to get the reactions at C, then move to a free body of this animal. Right? That should get that problem done. If you have any trouble with it, we can talk about it when we all get back together.